Nice to be back with you again. This is my last time with you, I think. So, as usual, I wanted to be interactive. As I'm going through and we're talking about these topics, feel free to stop and ask a question. Also, part of the way I think and present is that I like to get away from the textbook a little bit and just bring some real life situations into our discussions and experience. So just like last time, kind of the same approach, also including videos in the session, I think is helpful. All right. One of the things and you should be seeing on my screen right now, which I asked Dr. Jumbo to share with you all, is the 2020 to 2025 Federal Health IT Strategic Plan. Did you get a chance to take a look at it at all?
A little bit.
A little bit. Okay. It actually was just released last month, right? So it's fresh off the press here. And I think, if you get a chance, go through and read it. I still have to read it in total myself. It's nothing new that, from my experience, but I think it would kind of bring to full picture for you again the why you're studying what you're studying, what are you doing it for, how does it apply, right? And so there's information here I think that's pertinent and relevant to your studies, and just to give you an idea again about healthcare IT and what the government is planning over the next between now and 2025, right? And I'm scrolling, so hopefully I'm not getting anybody dizzy. But I saw, some of the things we talked about like last time. When you read this, you remember we talked about like the quadruple aim. You'll see kind of indirect references to that, right? About the quality of care, the population health, the experience, value-based medicine, right? And then and I'll stop after this, the vision and the mission that the Federal Health IT has for the nation. Again, the vision, you see the health system uses information technology to engage individuals. Remember, the lower costs, right? One of the part of the quadruple aim, deliver high quality care and improve individual and population health, that experience, right? And those outcomes. And then again, the mission for the Federal Health IT for the nation is to improve the health and well-being of individuals and communities using technology and health information that is accessible when and where it most matters. Exactly what we talked about the last time I was with you, and also I'm quite sure with the lessons that you've been doing with Dr. Jumbo. So do you see how it all is fitting together and purposeful for solving the healthcare issues that we have and to make a better system? What are your thoughts? No thoughts?
Well, I definitely can see the relationship between the quadruple aim to this document, but I think it's gonna take a lot of work for us to accomplish all these goals, and it'll definitely take a lot of effort.
Absolutely, absolutely. But I see pure opportunity, right? Pure opportunity.
Yes.
And I remember going through school, and I think I mentioned this last time, maybe just in passing. You learn if you take, for example, calculus and differential equations, like, why am I even doing this, right? Will I ever use it? And I was thinking about back in my days, it was called like new math, right? Will I ever use new math? Well, here again, just providing a little bit of information, you will use what you're learning, so take it in and digest it all, what's being shared with you, because it is applicable. All right, so let's get past that. I just wanted to share that, so take some time and read that. Let me put this in, let's see, presentation form. Is that okay?
Yes.
Yeah, that's good.
All right, so natural language processing, that's the first topic tonight. And natural language processing is kind of intersection between AI, artificial intelligence, and logistics, linguistics, not logistics, linguistics, okay? So our goal today and our objective is, define the natural language process, the type of communication, how it applies in how do you use it, natural language processing, and then maybe some of the challenges, kind of talk about that. So what is natural language processing? Can someone define for me? I know the definition is on the screen, but I want it in your own words, what natural language processing is.
It's a kind of way that the computer kind of process, like I guess, like you said, human linguistics, like the choices of words and all kind of like the grammars and all that to be used for other stuff to understand human language, I guess. It's kind of hard for me to explain. Sorry.
No, you're fine. You're fine. Yes. Right. Having a machine take the conversation that you and I are having,
Right.
and being able to interpret it and translate it into some meaningful way. And there are challenges with that, right? Obviously. So again, NLP, natural language processing, intersects between computer science, artificial intelligence, and the human language. And it's just amazing. I always am amazed at the power of our brains, right? Our own little computer chip in our head. Amazing, right? Because look how easily we do that translation and interpretation as human beings. But a computer has to learn how to do that, and really does not have that intuition necessary, especially for English. And I'm not bilingual. I know some Spanish, but even Spanish speaking, native speaking people, to understand and translate and interpret the English that we speak so natively can be a challenge. And we have this powerful chip in our head that's called a brain. Okay. One of the things that I've done here, and there's a video at the bottom of the screen here. I'm not going to go through it, but if you get some time and you want to listen to it, it's actually where I took some of this information from, but it's a lecture out of, I think, Stanford, okay, around natural language processing. So the goal of natural language processing, like you said, is to be able to, for the computers to understand our natural way of speaking, or tenses, or or verbiage that we share. Okay. It is a difficult goal. Why? Why? Why is it so? Why is natural language processing challenging?
Oh,
Sorry.
All right. Oh, I was just going to say that, like for English, for example, our language just in general is not as straightforward, and computers might take the syntax that we use to form sentences as literal.
Yes. Yes. Are you all programmers also?
No, not me.
in class, yeah, but
Learning.
outside, no.
Okay, sure, but you do programming. The last programming I did was Fortran, which I don't know if Fortran is still being used.
That's old.
Oh, thanks.
I'm sorry.
You are correct. But I can remember having these if then, right? And when I went to college, I went as a chemistry major because I thought I was going to be a research chemist, but I had to take Fortran. And I remember sitting in one of my no-nos is that I wait to the last minute to do things. So here it is. I have this this program was I had to program for a game, some sort of game. This was before Microsoft, you know, back in the days. And I remember I was in Rochester, RIT, having to write this program in Fortran. And 2 o'clock in the morning, snow is like 10 feet outside, and this thing wouldn't run because there was an error and I couldn't figure it out. Come to find it was like a little semicolon in the wrong place. And that's when I knew, oh my gosh, I don't think I can do this programming thing. Okay. But I remember these if then. Natural language that we're speaking, we don't have that, right? And a computer really is looking for if then. Okay. So that's part of that complexity. So having to be able to break down and translate that, you know, that syntax, that morphology, you know, the semantics and pragmatics. And I'm not an English major, so I'm not going to try to explain all of that. Definitions are here. Is part of the challenge that is faced with artificial intelligence, machine learning, right? Getting that word order in place, getting the meanings accurately translated, right? And those social rules that a computer has to know how to follow. So part of the taxonomy and the language for the natural language processing is that tokenization, right? Which are parts of word, the numbers, the symbols, okay? And here is an example for a result from a CBC, a complete blood count. Patient's WBC dropped to 5,000. So the patient's white blood cell dropped to 5,000. To be able to parse that out so that a computer can accurately understand and interpret it as part of the challenge. Okay. The lexicon, right? Words, identifying words to determine their categories, being able to categorize words within the speech or the text is important. And then the syntax, the grammar, you know, verbs, noun, pronouns, all of that, right? We have to be able to parse and break that out so that the machine can better process this information. So the different ambiguities, like we talked about, you know, in our natural language, there's ambiguity. There's a lexical ambiguity in when we speak, right? There's syntactic ambiguity, and then referential ambiguity. So logical ambiguity, here's a perfect example, right? She is looking for a match. Which match? Are we talking about the match that starts a fire, or a match like a husband, or a match like a match of a blouse and skirt? Which match are we talking about? How does a computer innately understand that? Okay. The fisherman went to the bank. Which bank? Did he go to the bank where you get money, or did he go to the bank of the river? Syntactic ambiguity. The chicken is ready to eat. I think in context, when we're talking, we understand and can figure out whether or not we're talking about the chicken is going to eat or is ready to eat, or are we going to eat the chicken, right? Again, how does a computer process that? I think all of these are very, very cute. Visiting relatives can be boring. Is it the relatives who are visiting that are boring, or when we visit relatives, it's boring? Okay, and even that referential ambiguity. The boy told his father about the theft. He was very upset. Who's the he? We're talking about the father, or we're talking about the boy? So these are some of the ambiguities that we have in our natural speaking language that is challenging in translating in computer processing. Okay, again, here's some more example, right? And also idioms, right? When we say it came straight from the horse's mouth, did it really come from a horse's mouth? It's raining cats and dogs. Is it really raining cats and dogs? You and I know what that means as idioms, but again, a computer, unless it's trained and coded appropriately, cannot make those contextual inferences. The human, us, we have no difficulty, especially if in an English sense, it's our first language, right? No difficulty making those correct interpretations. All right, I'm hoping that you can see, it's not too small. So again, just more examples of the cat sat on the mat. And this is a breakdown into different parts, parts of speech for each of the words in the sentence. And the whole point is that, okay, there can be possibly 1,512 different possible interpretations of this sentence. Okay? To me, that was mind-blowing, just kind of thinking about it. As a human being, every day we do this, and it's natural, okay? But again, a computer is challenged. AI is challenged. Machine learning is challenged in making these inherent inferences.
Yep.
Go ahead.
Oh, I just want to, I guess, point out like how we as a human, we have our common sense, but I guess for AIs, we kind of we have to code the common sense into it because it can't really, learn to have its own common sense on like how we do in our regular life.
So accurate. That is so, and it can get all philosophical and go, is it because we have a soul and the computer, as of now, let me see, today it's still 2020, so anything is possible.
Yep.
Does not have a soul, right? But the one thing that I think with AI, I mean, it learns, right? The more data you give it, the more it learns, which I just think is just amazing, right? And the potential of that, good, bad, or indifferent,
Of course.
Mm-hmm, mm-hmm. And so this next slide is talking about, taking ambiguity out of the language and these idiomatic references. And so this is just a reference I found that kind of talks about how do you take what would be required, right, in building a system to help to remove that language ambiguity that we just talked about, right? And so here's some examples, right? In an automated system, how do we tackle this problem? Okay, so there needs to be some resource, as an example, the first one, right, where you can program in these constraints and have these syntactic categories, okay, pointers to those categories that the computer can reference, right? Be able to parse the information, just like we demonstrated in the earlier slides, breaking it down into its different elements, parsing it out, right, that statement, and then assigning classifications for those words, noun, pronouns, whatever, verb, as an example, okay? A resource that would help, again, the constraint of the word sense. You have to program that in to the system. Their logical scoping context. It's all about context, right? The contextual reference. How do you code that and then train the computer to understand those contextual references? And then the last one I thought was interesting, again, to adjust for recency. Language changes, to me, quickly, right? And I will tell you, I mean, I'm Jamaican, and in Jamaica, we speak Patois. The Patois that I knew back in 1979, when I was 15, when I left Jamaica, those words have changed. And there's some words right now that if someone spoke to me in Patois, I'm like, I don't know what you're talking about, right? Again, my dictionary, right? My database for Patois has not been refreshed with more recent terminologies. Okay, so I'd be a bad AI for patois. Okay. This next slide, I think just I like pictures and diagrams, and I'm an auditory learner, but also very visual too. And I think it kind of gives you an idea, especially from a coding mindset, how things are organized. So the picture on the left again talks about the two different types of input we have into our computers, right? Speech or text. Okay, and then it breaks down the type of analysis, the morphological analysis, syntactic analysis, semantic interpretation, and then the discourse processing. And I've given a definition at the bottom of the page here for what discourse processing, because to be honest, I had to look it up myself. Okay. Linguistic structures. That's what it's really, at the end of the day, we take for granted, but not so easy for a computer system. Okay. And the diagram on the right basically is just a graphical representation of what I talked about in a couple of slides ago about those, the slide prior to this one, about those rules, those categorization, those constraints, right? You have to have some sort of repository with those things defined to help with that processing and organization by the mechanical system. All right, so I've got a slide here that sort of helps with that. Let me see, I may have to set this up 543. Give me a second here.
Features of text based on speech tag or some.
Okay.
Language processing, or NLP, is an automated way to understand, analyze human languages, and extract information from such data by applying machine learning algorithms. The data content can be text document, image, audio, or video. Sometimes it's also referred to as a field of computer science or artificial intelligence to extract the linguistics information from the underlying data. NLP enables machines or computers to derive meaning from human or natural language input. The world is now connected globally due to the advancement of technology and devices. This has resulted in the high volume of digital data across the world and has led to a number of challenges in analyzing data, including analyzing the tons of data that is generated in the form of text, image, audios, and videos. Identifying approximately 6,500 languages and dialects followed across the globe. Applying quantitative analysis on huge collections of data. Handling ambiguities while interpreting data and extracting information. This is where natural language processing proves useful. One of the main goals of natural language processing is to understand various languages, process them, and extract information from them. In NLP, full automation can be easily achieved by modern software libraries, modules, and packages. These software libraries and packages are aware of diverse language and culture and categorize data accordingly, which enables understanding sentiments better. With the help of these libraries, we can also build analytical models and automate the natural language process with minimum or no human interventions. NLP terminology. Now that you have understood why NLP is so important in recent times, it's time to make yourself comfortable with the NLP terminologies. 1. Word boundaries. It determines where one word ends and the other begins. 2. Tokenization. It's a technique to split words, phrases, idioms, etc. present in a document. 3. Stemming. It's a process to map words to their stem or root. It's very useful in finding synonyms and extensively used in search engines. 4. TF-IDF. It's a numerical value which represents how important a word is to a document or corpus. 5. Semantic analytics. It's a technique in vectorial semantics of analyzing relationships between a set of documents and the terms it contains by producing a set of concepts related to the documents and terms. 6. Disambiguation. It's a technique to determine the meaning and sense of words, context versus intent. 7. topic models. It's a type of statistical model for finding abstract topics which occur in a collection of documents. Now that you are familiar with the various terminologies, let's dive deeper into the NLP approaches to analyze text data. These approaches can be interrelated, or they can be independently applied depending on the type of data to analyze. Basic text processing. It's a way to analyze text and extract keywords that sum up the style or basic context of the text. For example, if the content is religious or fictional. Categorizing and tagging words. This approach is about finding lexical categories and automatically tagging each word with its word class. For example, tag a word using languages such as Chinese, Spanish, etc. Words can also be tagged as adjectives, verbs, nouns, and so on. Classify text. With this approach, you can identify particular features of language and use them to classify it. For example, classify the text as sports, politics, or technology. Extract information. This approach is about identifying the entities and relationships in a text to extract information in a structured way. For example, date, time, money, and direction can be used to establish relationships with other words available in the text. Analyze sentence structure. In this approach, capture formal grammar to describe the structure of a set of sentences. For example, find a well-formed or ill-formed sentence structure. Build feature-based structure. Through this approach, we get an insight into grammatical categories of the text document. For example, detect features of text based on speech tag or some grammar rules. Analyze the meaning. Perform quantitative analysis of the given set of data to extract the information. For example, find entities in the text and try to establish a relationship between them. In this demo, we'll view how to install.
Okay, so I'm gonna pause it here. Has any one of you programmed like Python?
Yeah, we're working on that.
You are, okay. So in your experience so far, have you had to do anything like this?
Natural language processing?
Mm-hmm.
I don't think so. We're still pretty in the beginning stages.
Okay, well, if you
Dr. Ibrahim,
go ahead.
this is just an intro. They're not programmers, so we're just introducing Python to them.
Mm-hmm.
Yeah.
Sure, no, that's good. And that's why I include the video, because you can, you know, listen to the video, look at it, and it kind of goes through and gives some additional information that at some point may find its way in your educational program. So at least you'll be kind of a little bit ahead of the game, just, you know, listening to it. So, all right, I added in the next two slides, again, screenshots from the video, just so you can use as reference, because I thought that information was well outlined by the speaker, and it's good reference. Okay, so when we think of, you know, examples where natural language processing experience that you may have right now, I just kind of put some examples here. The emojicons I thought was an interesting example of NLP, right? Never thought about it like that. Speech recognition, yeah, makes sense to me, but I never thought about the emojicons, right? And then sentimental analysis is what I guess they call the emojicons. And then of course, use of chat box and the machine translation. So just some examples of where NLP is used. And then for text mining, spell checking, when you do like a search on the web, right? And even advertisement matching. And it's so interesting because I really think Siri is listening to me, spying on me, because I say something and the next thing I know, I go to my phone, my Facebook or something, you know, and it's bringing up that advertisement to what I just spoke about. So I think Siri, she is snooping on me, but I guess that would be like an example of, you know, the advertisement matching. Did
Yeah,
someone?
I had that kind of feeling too.
I know, it's kind of creepy, huh?
A little bit.
Big Brother is truly watching.
Yep.
All right. Here are some cases that relates to NLP in healthcare. 12 use cases of NLP in healthcare. So, you know, we talk about speech recognition, improvements in clinical documentation, okay, data mining research, computer assisted coding, and it's, you know, an automated registry reporting. Just some examples, and there are more listed here. I thought it'd be good kind of, you know, where does it fit in healthcare? Any questions on any of these or any thoughts? Okay, and then, you know, the merging use cases, and then the next generation use cases, right? All right, in an example video, and I think I'll share some of it here. The speaker and the person was presenting asked, did a quick poll of the audience she was speaking to, and she asked the question, are you currently using NLP in your work? And of that sample, the population was there, 67% of the people said no, and 33% said yes. So I thought that was interesting, right? And so in healthcare, you know, where and ways that natural language processing is being used, right? So the EHR usability is one, predictive analysis, phenotyping, and quality management. So from an EHR, electronic healthcare record usability example, I wanted to kind of show that. By the way, this is an article. I gave you the reference here that I thought if you want to find it in your school library and read it, I thought it would be interesting, right? Talks about the clinical narrative. Clinical narrative is a way of documenting in healthcare, other than the point and click drop down on the electronic healthcare record. Interestingly enough, when I did my dissertation was a phenomenological study on the adoption of the electronic healthcare records by psychiatrists and psychiatric nurse practitioners in a behavioral health, community behavioral health. And one of the discussions I had with them, and I used the term inappropriate technology, right? Meaning that based on their feedback, they stated that they had a frustration with the electronic healthcare record and having to point and click and drop down, select options, because behavioral health is, their documentation is more narrative storytellers, but it's difficult to get discrete information, right, from a narrative. Okay, so this is part of the frustrations that clinicians face, especially if they're used to writing more narrative documentation. And so being able to leverage AI in a situation like that would prove to be very helpful. Okay, so the slide here, the bottom of the slide says, clinical narratives represent the main form of communication within healthcare, especially like in behavioral health, right? In comparison with generically coded elements of electronic healthcare records. The narrative notes provide a more detailed and personalized account of patient history and assessments, offering a better context for clinical decision-making. That to me is a very important statement. And if the clinician is not able to narrate, right, there is some aspect of loss there from a patient documentation, a clinical documentation standpoint, right? So as much as we do want to have the drop downs and clicks, we have to be able to pull information from that narrative. Okay. Some of the documents used in clinical natural language processing: discharge summaries, progress reports, radiology reports, pathology reports, okay? Clinical notes, psychiatric intake records. Again, just some examples of where that textual content is, or maybe even picture, right? If you think about radiological pictures. I don't know. And Dr. Jumbo, do you know whether or not we have technology right now that from an AI standpoint that can read an X-ray or an ultrasound and kind of pull from that? Do you know if we've gone that far?
No, I don't think we've gone that far. I think we're still exploring.
Okay.
Yeah.
So here's an example, and this was the example this particular person used, and I put the YouTube link there. You can go and take a listen to her discussion. Again, the comparison between, you know, the top part of the screen in red, you know, they're collecting social history. In the electronic healthcare record, you have the drop down, you can select that, easy, right? And then another example on the right where you have that clinical note, right? Where obviously it would be more difficult to pull information from, especially manually, or even, you know, a current EHR system that doesn't have enabled machine learning or AI to be able to read that note and then put it into some format that is easily extractable, okay, for reporting, et cetera, et cetera. One example she gave, and I thought this was, I don't know how old this was, but here's an example she said in the video where another clinician who has an IT background did an experiment of some sort, develop a model that they were able to use where she took the clinical notes and was able to organize it in such a way that it presented a timeline in tracking this particular patient issue. And then from the clinician standpoint, it kind of gave them a dashboard, right? So for example, I think the more bold and larger, like a word cloud, more bold and larger, the terminology is more frequent, that term was used. And then the highlighted dyspnea was what was searched on. So she took all of that narrative that was in those notes and was able to extract that and present it in such a way that the clinician looking at that patient longitudinal record is able to glean information easier than trying to go through every single note that was ever done on that patient over a period of time. Okay. Any thoughts around that?
It's pretty interesting to me if we are able to do that on all the patient charts, like everything is right there.
Yes. Yep. Perfect. All right. So challenges with NLP. I'm going to play this one, 1721. Give me a second here. Oops. Go back, get out of here. Let me find this, 1721. Da, da, da. Actually, I think I started it. Give me a second here. Yeah, okay, I'm gonna start this one. Oops. Yep.
At their institution. There are a lot of challenges to making NLP work, and I'm going to talk about 4 of them. The first of them is the old adage, garbage in, garbage out. If you can only extract information that's actually there and clear and easy to identify. And one of the things that's causing NLP a lot of trouble is that people are typing their notes now, especially at the VA, but also at other places. And because they're typing, they're doing a lot of shortcuts. They're creating templates, and they have the power to create all kinds of templates, any kind they want. And this is a big challenge for NLP, because if you're trying to, we're looking for sentences, and we are training our system on certain things, and handling these templates can be a real challenge. So this is part of the issue of we're only as good as the data that we're given. And a researcher at Florida found that there are 58 different classes of this type of information that's pasted into notes, including templates and tables and checkboxes. Another area of where it's really hard to deal with the data that you're given is that because people are taking shortcuts, they're copying and pasting. And we've heard about note bloat, and you're putting information in the note that's outdated or inaccurate. You don't know who the author is, and this false information gets propagated across the record. And so clinical notes are becoming less useful, and NLP can't solve that problem. The second area is NLP runs on text. And text is just a bunch of words, but what's the meaning behind those words? And so you can build a really simple NLP system, and it can be quite powerful. But how do you really model the meaning behind that? And as you start to get more sophisticated in your natural language processing capabilities, you have to have a way to model that information. And this is something that, when I started my career in NLP as a graduate student, I never intended on doing anything about information modeling. That was not my interest, but it has been the core of my work, because if you're not modeling it well, you just can't scale it out. And so for an example is, you want to find patients with a cough for decision support, let's say. And so you have to define cough, and we're going to define cough as at least 2 episodes of a severe cough in 1 year. All right, that seems really simple to a human. It seems like one idea. But really, there's so much information that has to be modeled under that. First of all, you have to start with the report itself and the information in the report and the mentions. You have to be able to find words that indicate that the patient had a cough. And then you have to know that it's severe and that they had the cough, not have the cough. But then you have to look over the whole report, and you have to look at the episode, and then you have to look at the patient level. And so there are all these layers of information that you need to model. And you might say, well, there are terminologies out there. We'll just map to terminology, and that's all I need to do to model the knowledge. And so the Unified Medical Language System is a thesaurus of thesauri. And if you look up cough in there are 25 different variations of cough that you can map to. So that's a start, and you do have to decide which types of cough you're looking at. Do you care about bovine cough, acute cough? There's all these different types. But then even more important is the information that occurs around the word cough. Do you care about how long the cough lasted? What if it changed over time? Do you care if it responded to treatment? How severe of cough are you looking for? And so all of this kind of information is part of your phenotype, and it can be found in the text, in the words surrounding the word cough, but you have to be able to represent that somehow. The third area is sublanguage. A sublanguage is a subset of natural language, and medical language is a sublanguage. It has a subset of vocabulary. It has different grammatical rules, kind of a subset of those. And it has these regularities and peculiarities that you can rely on. And so being able to model the language that you're using is very important to be able to extract the meaning of it. We all know that social media is a sublanguage. It has, new vocabulary in it. It has emoticons. It has abbreviations. And I know I'm not very good at using emoticons, and I put one in a text once when my daughter said something sad, and it was a little emoji that was crying, and I thought, I'm going to express my sadness to her, and she said that emoji that you put in there means laughing so hard I'm crying. So I obviously don't understand the sublanguage of social media, and so I shouldn't be using it. But your NLP system, you cannot take an NLP system trained on newspaper text and run it on social media and expect it to extract the meaning, because it doesn't understand the sublanguage. And so medical language has a sublanguage, and they're different. Medical blogs have one particular type of sublanguage, and clinical notes have another type. And you can differentiate them by their use of verbs, by the types of measurements they have, the types of semantic, the semantic types that they're using, and there's also a lot of grammatical and syntactic information. And so your NLP system cannot be just bought or downloaded off the shelf from a company that runs on newspapers or on, and you really have to be able to tailor it to understand the language that you're working on, and that takes time. The final area is just the variation that you see in language. And there's so much linguistic variation. There are so many ways to say the same thing with different words. And in English, one way that we get this variation is through derivation. And so you could say the same thing in an adjective form or in a noun form, and they really have the same meaning. They just have a different part of speech. Also, we have two types of inflection. Something can be plural or singular, or we also have tense, where it's in the present tense or the past tense or the future tense or all the other tenses that we have. And English is a lot easier than other languages in terms of inflection. But your NLP system has to be able to understand that cough and coughed really are the same concept. But one of the main challenges to NLP with this variation is the synonyms. There are so many synonyms for the same concept, and you'll never run out of new things that you do not have in your dictionary. And you think you may have a really complete dictionary, and you'll just be surprised at how many ways people can say the same thing. On the other side of the coin is polysemy. Polysemy is when you have one word, but that one word has multiple meanings. So you may have to differentiate between the different word senses of a word like discharge. Are they talking about discharge from the hospital, or are they talking about stuff that comes out of your body? And again, a big challenge to NLP is the acronyms and abbreviations. And when you see APC in a text, what does it mean? Does it mean activated protein C? I mean, it just goes on, the number of meanings that acronym could have. And so that's one of the big challenges, getting an NLP system to work the way that we as humans understand. Okay, so now I got you all excited, and then I depressed you. So now I'm going to conclude with, you can still do it. There are a lot.
Okay, I'm going to pause it here. I'd like to hear your thoughts around what she presented.
Well, I think, like she said, she did say the English language is easy, but I'll say it's versatile, which makes it harder for I guess machine to actually learn what we really want to say.
Could it also be like how different states say different words, like for soda and pop? So it's like machines can't figure it out unless we tell them to.
That's a great example, actually. Yeah. Anyone else? All right. So the last slide I had for this is I just added an additional video here again that you can, if you take the PowerPoint, just kind of go through it, just different aspects of natural language processing. And I think in this one also, he talks about the programming aspect of it. And he gives a link to a data site, a site where you can download open source patient data, anonymized patient data, which actually I'm going to take advantage of for something that I'm working on for a blockchain project. So I have to sign up and do that. So that was enlightening for me when I found this video. So I'm going to share it with you. Take some time and go through it. All right. So the next chapter is, let me put this up. Okay. Management of information, okay, in healthcare organizations. And so our objectives for this session is, again, defining the management of healthcare information organization, defining and discussing the process of moving data between systems, understanding the major components of an integrated delivery network, okay? When we go through, yeah, I think it's the next one. Do you all have access to your school library?
I believe so.
You should.
Okay.
Yeah.
You should.
Okay,
have
good.
access to it.
Good. Okay, good. All right. So it's actually the next session. I was just kind of thinking ahead. I'd like for you'll be able to log in. So just get prepared for that. Okay. All right. So healthcare organization, HCOs. One of the big challenges with a healthcare organization, right? And as you've seen, just in the information shared between me and or Dr. Jumbo, is that healthcare data, there's a lot of it, okay? It is information intensive. And any healthcare organization has to be able to manage and share that data. And since paper and having paper charts really is not the most efficient way, in fact, now our healthcare organizations are required to have an electronic healthcare record system, right? The healthcare information system, the computer, is used to help to manage this massive amount of data, patient data, okay? So one of the things that a healthcare system, right, the computer system, information system must be able to do is to be able to organize and manage and then integrate large amount of both clinical and financial data, right? Clinical data and like claims data, right? Insurance data, okay? And be able to hopefully be interoperable as much as possible, okay? But be able to manage and effectively and efficiently handle that data. So what are the benefits of a computer system like a EHR, right? Electronic Healthcare Record System that we've talked about, right? And again, it goes back to, if you look at these bullets here, it goes back to that quadruple aim, right? For more value-based care, reducing the cost, okay? Having paper records and the errors that go along with that, expensive, right? So hopefully the implementation of a healthcare information system reduce that cost by reducing that paper burden, reducing that potential for error, increasing efficiency, right, for your staff and for the treatments of your patients, right? Making you be more productive, okay? Helping and enabling, better enabling quality care delivery and quality outcomes, okay? And last but not least, that regulatory compliance. You have to be in compliance with the regulations, right? Whether it be HIPAA, we'll talk a little bit more about that, or meaningful use, okay? Or other type of healthcare related compliance requirements, regulatory requirements, okay? Your system should help you do that. So how do you move data between systems, right? An interface engine, for example, one that I've worked with, like Ensemble, is an example. Rhapsody is another example of an interface engine. And I'll show you a diagram about that. HL7, right? Health Layer 7 is a standard. We talked about standards last time, important for interoperability, but HL7 is a standard for sharing data between healthcare information systems. And even more recently, HL7 Fire, right, is being promoted right now, and APIs are being developed and interoperability standards are around Fire is being developed, right, to better enable and close that interoperability gap. Okay, have you heard about HL7 and HL7 Fire?
No.
No? Okay. If you get a chance, you can go to, I think it's hl7.org. Let me,
Yeah,
I think it's
that is gonna be our topic for next week, next class.
oh, good. Okay, so I'm giving you a head start. Haha. So you can go, you can go and take a look, you know, and let me move this out the way here. Hold on. hl7.org, right? And you can kind of get ahead of the game before you get to Dr. Jumbo's class. So you can really impress her. So she's like, yeah, they got it. So look at those standards, kind of read up about it. It's kind of interesting, okay? I gave you some examples why HL7 Fire is the next level that we're going to, right? That the Office of National Coordinator and CMS are working to establish as the next version for data exchange between healthcare information systems, okay? And there's some benefits for it. And I've listed them there, okay? So here's an example of, if I were to look in the interface engine or in the interfaces for an electronic healthcare record, this is the HL, and again, I'm not going to the details of this, but here is the HL7 interface message for this patient, right? And each of these segments, these messages and the segments has a meaning. Okay, if you go to the site I just showed you and kind of read through that, you can know what the MSH is, what the PID is, you know, what the PV1 segment, these segments are, okay? But just as an example, you can see within the PID, the patient ID, right, where female is noted, right? So each one of these segments has a particular requirement for that standard. So when it goes from one system to the next, it knows how to file it, okay? And here's another example for this phone number for this patient, right? It's in this PID 13.2.1, okay? So just giving an example of what that message looks like. So, you know, in my past life, when we did our integration and, you know, someone on one end, let's say, for example, I'm on the EHR side and I order a lab test on the front end of it, you know, the GUI side, it then translates into this message format. It goes through the engine and then gets to the lab system, right? The lab system then sees it on the GUI end, responds to it, runs the test, the results come back. And then I'm on the EHR side and I'm like, where is the result? I don't see the result. Well, possibly that message failed, right? And it may fail and you can look at it in the interface engine and see where it failed. Maybe the gender was a required field, but when that result was sent back or whatever, I'm just making this up, the gender was not there and therefore the engine says, hey, it's missing something, let me fail it, okay? So that's how that is used. Here's an example of the FHIR. And again, FHIR, you see, it looks a lot different than the standard, the common standard HL7 message. This is the FHIR resource coding. I just gave an example so you can kind of, you know, see the differences, okay? Here is an example. This is actually from one of my past clients, right? So this is a very large organization with multiple, and can you see this okay? Let me get out of here and I'll make it larger this way. Okay, this is an interface diagram, okay? Have you ever seen something like this before?
No.
No.
No? Okay, all right, no problem. So in this example, EPIC is the EHR, the electronic healthcare record. Rhapsody was the interface engine, okay? And each of these was a different software. So here's PeopleSoft, here's Omnicell Supplies, right? So like, for example, cotton balls and syringes, right? They track that there. Provation is a computer system that they use for the GI department, right? Here is the radiology, and so for radiology, cardiology, their imaging, these are some of the computer systems that they use for this particular organization, right? So you can see PowerScribe, Radiolog as an example. Uptime, materials management. So this is for like the surgery department, right? So each of these departments has a different computer system, right? HIM, so for the health information management, the records department, right? M-Modal was like a transcription software, as an example. Highland on Base is where they store documents, like a document store, okay? Resolute Professional Billing. So the whole point, this is ASAP for the ED, so for the emergency department, okay? This is the lab department, SunQuest lab, okay, the reference lab. My whole point is that all these different departments in this hospital system has their own record manager of some sort or electronic system, and they're all tied in, right, to the EPIC EHR. Each of these, let me make this larger. Okay. So each of these, you see the DFT, you see the ADT, you see the SIU, you see the ORU, you see all of those arrows? You see those?
Yep.
Yes.
Okay, these all indicate those HL7 messages that are sent between systems. So for example, the surgical SIU, that SIU message is a scheduling message, right? So patient in, they register them in EPIC, they create a appointment, right? It's sent over to Provation. Okay, patient comes in, they check them in, Provation gets the scheduling message, go, patient is here. The GI department now know the patient has arrived, okay? The ADT message is again an HL7 message, okay? It's their admission, discharge, and transfer. So it'll have like the patient's demographic information, patient name, their date of birth, their address, all of those types of things, okay? So in behind the scenes, right, we talk about exchanging information between systems in a healthcare system. This is one example of what this overall architecture looks like. And it's managed through that interface engine, and the communication happens through that HL7 standard. Make sense?
Yep.
Yeah.
What questions do you have?
Oh no, I just saying it's understood.
Okay, all right. I don't know. It's exciting to me, interesting to me. I don't know. It just, you know, it takes, for example, all the theory that you're learning, and now you've seen the actual demonstration, right? This is an actual example of what healthcare information system, the EHR like EPIC, what the nuts and bolts are behind the scenes that allows that information to transmit from one system to another. That's the whole idea, okay?
Okay.
All right. So that's the granular aspect of it, but bringing it up the 50,000 foot level, you know, when you talk about a whole system, right? An integrated delivery network, right? Meaning that a healthcare system has different, what I'll call service delivery actors, right? Who provide service to patients who have to all communicate and communicate securely, right? So again, here this is this example where you have a healthcare organization, you have the clinic, the long-term care, the reference lab, the physician practice, all of those people, right, are communicating, whether it be via cloud, if it's cloud-based services, or what we call on-prem, right, the service on site. All of that communication, really what's happening behind the scenes is this picture here on your screen right now. Okay, the devil in the details. And that's the complexity, right? It's healthcare and healthcare information technology and healthcare delivery and healthcare records management and healthcare system architecture is very, very complex. Okay. All right. One of the other things that I shared, I don't think I put the link in here. I should have, but you can search for it online, right? So the Office of the National Coordinator, ONC, released last month also the final rules for interoperability, right? Even though because of COVID, they kind of pushed the requirements out until 2021 and 2022, okay? But the ONC Cures Act and the interoperability rule, right, are the rules that providers and vendors, okay, will have to comply with to ensure that there's interoperability, right, between systems, or work towards that, okay, and to be able to, again, give patients and their providers secure access to health information. That's the whole point of this, of all of this, okay? Sharing of that critical patient information seamlessly. Other rules that you need to be aware of, okay, is the information blocking rule. Okay, that was just finalized, I think, earlier this year. Again, new requirements coming out that are being initiated by the feds and using that the ONC and CMS to ensure that there is not a barrier or barriers to the exchange of patient information securely. So be informed, right? You're in the field, right? You're studying this information. Recognize how the rules and requirements of the industry forces compliance and forces the architecture behind the technology that we use to enable care delivery. Please take some time and read up on these. All right, so what's an integrated delivery network? I just have a little video. Let me check my time here. Okay, I have time. I thought this was a nice little video. So you hear the term, what does it really mean?
All right, panelists, we're going to move into our second topic, and that's integrated delivery networks, their impact on healthcare delivery, and specifically on oncology care. So it's interesting that, you know, I came into the industry, the side of medicine 7-8 years ago, and I didn't know the term integrated delivery network. It's actually remarkable. You know, how many acronyms I didn't know and how many confused me. I mean, who knew that TA was not temporal arteritis, but rather it was treatment area. And I really struggled to see why they want to invest so much money in it. But nonetheless, as I've gotten to learn all the acronyms, IDN is a big one. And I don't know when hospitals became IDNs. I don't know historically, but in our first time, we talked a lot about consolidation. And to me, part of what's happened in the last 2 decades of consolidation in healthcare, a lot of it has been to take these hospitals and make them integrated delivery networks. And so I guess I'd like to begin this segment to really allow all the viewers to get a better handle on your perspectives on when did hospitals become IDNs? What is how do you define the IDN movement of today?
So obviously, I think we alluded to this a little in the previous discussion, how hospitals have realized that they are not islands that provide inpatient care, and they are now distributed. They are at least currently the anchor, but perhaps will ultimately not be the anchor of a distributive healthcare network that provides care across an entire continuum, ambulatory, inpatient, chronic care management, all the things that are happening. Obviously, the acquisition of physician groups and multi-specialty practices has been a big part of that transition to the IDN. And quite frankly, I think the other driver, and although we're kind of in the early phase of this in cancer, oncology care has been at the forefront of this, of the idea of multidisciplinary care that is organized around the patient's medical condition as opposed to the specialty of the individual practitioner. And Mike, you alluded to this, earlier a little bit. And so I think that oncology has been the poster child for this. You look at some organizations like Cleveland Clinic and others that are starting to organize care across the entire continuum around specific medical conditions. So there's the Cardiovascular Institute, the Gastrointestinal Institute, and you've got physicians coalescing around a patient. And I think we as a system are starting to understand that patients don't come to us with a diagnosis of surgery or medical oncology or radiation oncology. They have a disease, and we need to figure out how to do that. And the IDN is a platform with which to do that.
So Dana, are there components that are required to be an IDN? You have to have a hospital. You've got to have a provider network. Are there pieces that make it? Is it just any hospital if it's big enough as an IDN, or what makes it integrated? What are those services that are required?
I think that there are many services that are required. It gets to Mike's earlier point about having some breadth. So for instance, a lot of them are bringing in and acquiring home infusion services, for instance, as part of the integrated network. And that makes sense to them because they are better able to coordinate that care. They're also able to keep that patient within the system if home infusion is the best thing for that patient. So I think a lot of it is being able to retain that patient in general and offer what is best for them.
Yeah, so I think with the exception of surgical specialty hospitals, virtually every hospital that we might encounter, I think would fancy themselves to be an IDN. And this has really happened insidiously over the years, right? So all of us know that hospital systems have bought nursing homes. Hospital systems have bought physician practices, typically procedurally oriented, very lucrative physician practices, oncology practices where they had a lovely revenue center that came along with the acquisition of the practice. Orthopedics, another great example. I think this has happened both in urban and rural settings. I think it's happened nationwide. I think the reason to do it, which was to diversify and capture more of the patient dollar, has changed a little bit. Because I think we're in a universe where being more efficient and controlling costs may put you in a better negotiating position with a payer, and you cannot control what you do not own. And so as participants in the oncology care model have unfortunately learned, post-acute care costs a lot of money. And nobody asks the oncologist which nursing home to send the patient to, because the hospitals don't care what the oncologist says about what nursing home to use. But the hospitals have caught on to this. But the reason for their existence is changing because of risk and managing cost and managing population. Right? So I think it's a natural evolution from a true fee-for-service model to a different model.
And to your point, you can't enter into an ACO agreement,
our health system is a Medicare shared savings ACO. We're currently in one-sided risk. We've done well, but we have to have primary care, specialties, all the sites of care. We have to partner with community physicians.
But often
as
those
well.
are partnerships not owned.
Well, we own a lot, and then we also partner with those that we do not own. But what gets interesting, of course, is one-sided risk is going to go away, and everybody's going to have to take two-sided risk. And if you don't have a network that's diverse, you can't do it.
So it's interesting as we talk about all the different drivers for the IDN movement, and yet one of the outcomes of the IDN movement has been hospital closures, and we're averaging right now, according to an article published yesterday, 30 a year. And where those closures are most likely to take place are in rural areas, and we're starting to get some major gaps in coverage. And so it's interesting when we think about kind of roles and responsibilities and the kind of the original civic design of our healthcare system, and the nature of what's happening as a result of these drivers, much of which are financial. But some of it may often relate to performance metrics, where populations do better because we know that lower socioeconomic populations also have usually lower healthcare outcomes and greater reliance on certain healthcare services because they lack either financial or social service support. But it raises some kind of interesting questions, that are very philosophical but also pragmatic. How does our healthcare system, kind of address kind of core responsibility in dealing with the health of the population?
All right. Cancel. I want to do that. So I'm curious to know what you took away from that presentation around integrated delivery networks. Can you hear me?
Yes.
Oh.
I guess it would be an important consideration for lowering the healthcare costs in the nation.
There are cost considerations for sure, right? Efficiency is also, like you said, a driver. Okay. One of the things I took away from it as I listened to it, again, as I mentioned before, is the complexity of what it takes to deliver care to a patient, right?
Yes.
And so the question is, if you have an integrated delivery network, going back to, again, the whole picture, okay, there has to be some way to easily share that patient record, that patient information. And what allows us to do that? The healthcare information system, right? And it helps them to, again, cut their costs, right? Economies of scale is what's mentioned here, okay? And here's a more simpler diagram about that whole architecture, right? What is required? I guess this is from Mountainside Medical Center, their HIS, okay? All the different components of a medical record system, electronic medical record system, and its integrated counterparts are required to make that IDN a successful venture. All right. One of the things I wanted to share with you also, again, talking about healthcare system, having that data integration, both similar and dissimilar information, and really the process integration. I will tell you that usually when a healthcare system implements an electronic healthcare record system, they're truly doing an overall transformation, right, of their healthcare environment, okay? And you talk about organizational change management. I don't know if you've heard that terminology before, but it truly is a process and workflow reengineering in some aspects, right? one of the things, and Dr. Jumbo, she was more in the application side, she can attest to, is that when we start doing workflow analysis within these systems, especially if one system buys another system, like in these IDNs, and they sort of bring them all together, and then they have to figure out what applications they keep or what they don't keep, and change workflows and change processes. One of the things that you'll find is that implementing this computer system will reveal all of people's bad habits and the bad actors. Dr. Jumbo, do you agree?
Totally agree. Reviews all the dirty on the ways.
Yes, it does. And not everybody will be happy with us. Okay. We think we're there just to put in a computer system, but we've just come in and unfortunately upset a lot of people's status quo. Okay, we don't mean to do it intentionally, but that does happen. So a computer system is truly an agent of transformation within a healthcare organization. Okay. Another thing, I think this is my last couple of last slides here. Another thing I wanted to introduce you to, and again, you can spend some time reading about this. When we talk about standards, right? Here is a data standard that's required now. And I think I have time for this. Just a couple of minutes long. In terms of the core data for interoperability, what needs to be exchanged between systems, this is something to be aware of too, right? And if you go into programming from here, you'll.
The United States Department of Health and Human Services has been on a mission to empower patients with seamless access to their healthcare records since 2009. This was the year when EHR systems rendered paper-based healthcare records obsolete. The need for interoperability in healthcare technology as we know it today soon followed the introduction of EHR systems. More than a decade later, the interoperability of EHR systems is set to be driven by USCDI, the United States Core Data for Interoperability. In its basic form, the USCDI is an aggregation of standard clinical data elements that all HIT vendors are now required to conform to. It represents the most granular level at which a piece of patient data is exchanged by HIT systems. The ONC's goal with USCDI is to implement a common template for the digitization of clinical data. As all HIT vendors begin to implement this common standard, it unlocks two strategic advantages for them. It makes the integration with third-party healthcare applications easy, vastly improving the marketability of the HIT vendor's product. And it unlocks new possibilities to improve the continuum of care. As cost of expensive integrations, customer times comes down significantly with everyone in the ecosystem adopting USCDI. There is one important thing to note though. All CEHRT vendors must now conform to USCDI requirements since the release of the Cures Act final rule on May 1st, 2020 mandates it. HIT vendors, especially EHR product specialists, must now conform to these changes that are accompanied by strict deadlines. If you are an HIT vendor and watching this video, you're in the right place. Stay tuned to our feed to know what changes await you for successful compliance.
Okay, so just bringing that to a close here, just going to give you a little bit of oversight, introduction to the clinical data that needs to be exchanged within that IDN as an example too, right? Other critical consideration that needs to happen within that integrated delivery network or just holistically across the board for healthcare systems, security and confidentiality, very, very important, okay? And HIPAA, you'll hear about the Health Insurance Portability and Accountability Act is one of the moderator of privacy, security, and exchange of data within the US. And then, of course, GDPR is what I added. Yeah, in 2018, the European Union established GDPR, basically the right to be forgotten. Okay, so if you're dealing with someone from the EU, that's something that you have to take into consideration from a regulatory standpoint. They have the right to be forgotten. How do you handle that from a standards and a programming and a data management standpoint? Okay. All right. Okay. And I had a video here you can take a look at. Any questions before we transition to the last topic? Alrighty.
No,
Mm-hmm. You have a question?
no, I was saying no, no question.
Okay. All right. Awesome. All right. Let's go to the last one. So, information retrieval and digital libraries. All right. The objectives. All right. So, defining what an information retrieval and digital library is, and sort of discussing that information. Again, using video, we'll talk through some of this information. Okay. All right. What's a digital library? Right. It's a collection of electronic documents, right, that you access electronically through a network. Okay. Sorry, it's a little bit dry here. And then, like the slide says here, the classic research area dealing with electronic search for documents is called information retrieval. Information retrieval, basically doing a search, okay? And do a search, it's basically acquiring knowledge, right, via search, okay, in electronic system. Just more definitions around what the IR is. Okay, information retrieval system is a software system that provides access to books, journals, documents, etc., electronically. What's the difference between data retrieval and information retrieval? I thought this was an interesting distinction, right? So information retrieval deals with natural language text, okay, which is not always well structured and can be semantically ambiguous. We talked about that in the first lesson. And then data retrieval, right, is basically a database, right? That's a system, a database deals with data that has a well-defined structure and semantic. I think that might be on a test, huh? I don't know. All right. Let me play this video here. Let's see. Yeah, this is a short one also.
Need and objectives of digital libraries. According to Edward A. Fox, a digital library is defined as a machine-readable representation of materials which might be found in a university library, together with organizing information intended to help users find specific information. A digital library service is an assemblage of digital computing, storage, and communicating machinery together with the software needed to reprise, emulate, and extend the services provided by conventional libraries based on paper and other material means of collecting, storing, cataloging, finding, and disseminating information. William Arms has focused 4 aspects of digital library in an informal definition, and these aspects are managed collection, associated services, digital formats, and accessible over a network. He says that a managed collection of information with associated services where the information is stored in digital formats and accessible over a network is an informal definition of digital libraries. According to father of GSDL, Ian Whitten, digital libraries is defined as a collection of digital objects, including text, video, and audio, along with methods for access and retrieval, and for selection, organization, and maintenance of the collection. According to Les, a digital library is a collection of information that is both digitized and organized and which offers capabilities beyond those of the traditional library. According to our own missile man, Dr. APJ Abdul Kalam, the former president of India, digital library is where the past meets the present and creates the future. Let us discuss the need for a digital library. It is needed to provide perpetual access of digitized or digital objects, to eliminate geographical border, space, time, and barriers of information, to cope up with the increasing demand for information services, to improve efficiency in searching and indexing, to enhance existing services and start new information services, to save the time of users and staff in the creation and utilization of information services, and finally, to provide better management of digitized resources. The main objectives of a digital library are as follows: to collect, store, organize, and access information in digital form via communication channels, to meet the requirements of patrons by providing better services, to provide personalized and retrospective services in efficient way, to have large digitized databases, to save time of library staff by avoiding routine jobs, to provide coherent view of all information within a library in any format, to serve widely dispersed communities throughout the network, to minimize massive storage and space problems of large libraries, to reduce cost involved in various library activities.
All right. So I hope that gave you a nice little overview, better than I did, about what a digital library is. And again, based on queries, searching contents, using the search engine, using the metadata to retrieve information electronically. This is a great summary slide of that. All right. So I always like to ground my information in examples, especially as it relates to healthcare. So one of the great purposes for having a digital library is to be able to search information about medical condition that could help with evidence-based medicine, right? Okay, and so when there's a way to do that, I think nurses or doctors are trained to, or researchers are trained to, and I just wanted to share that with you, right? So when you're actually use a digital library to search for information in a structured way, right, by phrasing the clinical situation in a question, identifying the evidence that address the question, and then use your clinical judgment, if you're a clinician, right, to determine whether or not it applies to a patient. So again, the library is there, it's full of information, but how do I use it? What's the why? Why do I even have this great vast amount of information? Again, for patient care based on empirical evidence-based medicine, okay? And I won't go into details about this particular pyramid, but I'll leave it here. You can use it as reference, and then I'll play this video because I think it gives a great explanation about this research approach. This pyramid is called the 5S level, but I think the slide talks about a 6S level of how to really go about when you're searching a digital library, how to do that in an effective way. Okay, let's take a look quick. I probably won't play the whole 8 minutes, but just enough to give us a flavor.
One of the key activities of evidence-informed public health is conducting an effective and efficient search for research evidence to answer your practice-based question. However, searching for research evidence can be a daunting task. Relatively few public health professionals tell me this activity is a highlight of their workday. Searching for public health evidence can be challenging because there is such a small amount of it in comparison to other health-related topics. The 6S pyramid gives us a framework to structure our search for evidence. It provides us with a map showing us where to start our search and where to go next to find what we are looking for. Whether you have a librarian who conducts searches for you or you do them yourself, the 6S pyramid is a helpful guide. So let's take a look at how it works. Research evidence on a topic is first produced in the form of a single study. Single studies make up the lowest level of the 6S pyramid. At this level, there may be many studies available on a specific topic, and it could take years to review them all. So single studies are a poor place to start a search. Synopses are written for single studies and outline the key messages of the research. Synopses of single studies make up the second level of the 6S pyramid. You can imagine how much easier it would be to scan through brief summaries of studies to find research evidence. Synopses make it easier for you to find studies relevant to your question, but searching through them can still be a laborious process. Furthermore, currently there is no single source of these for public health, so we move up to the next level on the pyramid. As more and more research becomes available on a topic, the information from single studies may get combined in a systematic way into one document. These reviews of the literature, known as syntheses, make up the third level of the 6S pyramid. At this level of the pyramid, the results of many single studies are synthesized into one document, so there are fewer documents for you to go through.
Okay, I'm gonna pause that there. The whole idea is the digital library, right, has different levels of information, right? And the question is, how do you use that information in a smart, structured way to find evidence, right, for patient care, for evidence-based medicine, okay? And so one of the things you'll see here on the right-hand side, sort of where some of that information resides, right? Within the EHR, within, textbooks, evidence-based textbooks. One of the references here where there's systematic review, you see PubMed, okay? This is where journal articles reside. So what I'm gonna do is show you as an example how to search in a digital library such as PubMed, okay? And what I'm hoping that we can do if time allows is to basically take the same scenario that will be demonstrated here on this video and have somebody volunteer to log into their school library and see if you can perform that same search. So can I have a volunteer first who would like to do that? Don't be shy. Nobody?
How to do a search?
Yeah, in your school library, based on what's going to be demonstrated here.
Oh, I haven't really accessed the school library yet, but yeah, I could try.
Okay, all right. So I believe, let's see, you have a Downstate. Let me go here first. I'm going to open. Where am I? Do you have access to this? Have you ever used this site before?
Oh yeah, I did. For the research. Yep.
Okay, so I'm gonna put this in the chat, this link in the chat. Okay, excellent. Let me go back here. So let me pull up this video and you'll see sort of what she does.
Today, we're going to conduct an advanced Medline search using PubMed to find information relevant to a clinical scenario. If you're already familiar with evidence-based practice, then you know that searching the literature is the second step of BP, and that comes after the first step, which is asking a well-defined, answerable question. This is a description of the case that we're considering in this search scenario. A 30-year-old male patient was diagnosed with depression, and he's expressed that he would prefer to use alternative medicines rather than SSRIs. You, as his physician, believe that his disorder would be improved with SSRIs, but he wants to know if St. John's wort could be just as effective for reducing symptoms of depression. The first step of searching the literature is to take the case scenario and separate it into individual concepts, breaking it down into a PICO question. This way it can be translated into a search query for the database. The P element of this question is depression. The intervention that we are considering is SSRIs, and the comparison in this case is St. John's wort. Now, the desired outcome in this scenario is to reduce depressive symptoms. We are not going to search for that terminology because it's already implied by searching for depression itself. But anytime you are faced with a clinical scenario, it is still a good practice to write out your full PICO question because it does help to guide you throughout the search process and when you're reviewing the articles as well and looking for the information that you need. Now that we've determined the individual concepts of our PICO question, the next step is to choose terminology that the database is most likely to understand. The controlled vocabulary used in Medline is known as MESH, which stands for Medical Subject Headings. From the first page of PubMed, you can find the MESH database here, and this is where we can search for the best terms to use. Let's search for depression. Here are the results in the MESH database of terminology. You'll see there's depression and depressive disorder. It's important to read the descriptions here carefully. Depressive disorder is the term that would be best in this case because we're not looking at depression as a temporary state of mind. In this case scenario, it's actually a disorder. As you plan your search, it's helpful to have a scratch paper or something similar to this table where you can write down the good search terms that you find as you identify them. Let's find the next term. St. John's wort does have a different MESH heading that's different from the more commonly used term. This is a good example of a time to use the OR operator in a search so that you can retrieve everything that uses either the term St. John's wort or the term hypericum. Now we're ready to begin building our search, so we've got to get out of the MESH database and back into PubMed. The easiest way to do that from the MESH database is to scroll down and click on PubMed here. And now what we'll do is go into the Advanced Search Builder to combine all of our concepts. Now that the search terms are entered correctly, all we have to do is click on search. For your future searches, be sure when you use this builder all at once that anything on the left is connected with AND. Notice that we are searching for two different terms here, and the OR is in the same line. Here are the results of the search. There are a couple of filters that can be applied to reduce the number of articles that we need to look through. Another filter, if you have too many articles to read, is to choose the language. We don't see it here, so we have to click on Show Additional Filters,
I'll pause
Languages, say Show, and now you'll see we can click on English. You know it's activated when it has the blue check mark next to it.
Okay, I'll
click
pause
on
this here. So what I would like, and again, no wrong answers here, is for us to, to do the same search, just investigate. I mean, I tried it myself in my own university alma mater library system. I can say I didn't get the exact same listing that she got. Again, the time difference. I don't know how long ago she did this, but I got a different set of listing. But I just want to kind of go through the exercise with you all so you get an idea again about, the digital library, searching it, right, and applying it to healthcare. The why again, right? So, who wants to, let me see, if I stop sharing, maybe you can share your screen if you're logged in. Would that be okay?
Yes, that's fine.
Okay, all right. Let me just go through here. And again, the same case we're gonna use, search for depression as an example. So let me stop sharing. And then can you take the ball, or do I need to do it here?
Sure, I think got it.
Okay, awesome. All right, and you're in problem. Oh yeah, okay, good. You started out.
Yeah.
So walk us through what you did so far.
Oh, I guess I kind of followed through with what she did in the video. So I did search up for depression and kind of just click through depressive disorder, try to search up SSRI. And right now I'm at St. John's Wort page where there's also a search result for hypericum.
Mm-hmm. Good, excellent.
And I guess she went back to PubMed and just pretty much did the advanced search.
Mm-hmm. Mm-hmm.
So that will be so this. Oh, it's already inside in the query box. So,
Mm-hmm.
so might as well SRI and St. John's Wort for hypericum. I believe this is pretty much what she did. So I'm just gonna press search. Actually, I haven't really seen what was the her results was, but this is the results we have.
Can you open that link up? Let's take a look in it and see what aspects the artifacts of that article is. Just
Sure.
Okay. So some important things, for example, the DOI, and you saw that probably in your textbook, is important to be able to find that document. So if you should ever take that DOI number, the 10.105, etc., and search for it on the web, it would take you to that article, obviously.
Yep.
Right. The citations, all of that, the authors, everything. So that's good. Thank you so much for participating. Anyone have any questions? Okay.
All right, I'm gonna stop sharing.
Yeah, excellent. Thank you. Thank you. All right, let me share back. I think. All right, let me see. So I think that's where I stopped. And again, I just added her search terms and kind of the progress of what she did. So you can have that as a reference too. Okay. And the Downstate library just wanted, because I realized you may have access to it, but again, on the slide, it lists some other libraries that you can, I don't know if it's open access to you all. But again, within those libraries, those articles with the bibliography, you can find from that bibliography in that article, it'll kind of take you like breadcrumbs to other information in your research, right? The full text or the abstract, you can find information there. Okay, when you write your papers. Do you guys have a term paper due at the end of the semester?
Yep.
Oh, good. Okay. So you can leverage some of this skill, hopefully, to help you find information.
Yeah, definitely.
Yep. Even, I mean, this PICO search is for evidence-based, but I think you can even glean from this to kind of help you organize how you search for information, right? I thought it was a kind of a good strategy that you could leverage, modify to your own needs. Yep. All right, that is all I have this afternoon. I'm all done. Again, I hope you had a wonderful time and learned a lot. I appreciate your giving me your time. And Dr. Jumbo, I appreciate you having me as your guest lecturer.
No problem. Thank you so much. This is a very beautiful presentation. Everyone, will agree with me that this was very knowledgeable. Thank you.
Yeah, definitely. Thank you.
Great class. Thank you.
Yep.
Thank you.
My pleasure. And I'll give you 6 minutes back, right?
Sure. While we wait for the final result. Anyhow.
All right.
All right. Have a wonderful rest of the night. Go do your test.
All right. So any question? So we'll have one more test to go, right? Hang in there. It's almost over. One more to go. And I believe we'll have a break next week, right? The 11th?
Yes.
Yeah.
Yeah, I'm sure you're looking forward to that. So now that you've learned how to search evidence-based articles, it is an opportunity to begin to, to look for article for your final paper, your term paper. Use this opportunity that you have right now to work on your final paper. All right, any question, anything that is not clear? What is pending? What is due? I believe everyone knows exactly what is due. To take a quiz. If you have any issue, email me. Sometime Blackboard and responders have their own minds, so keep me in the loop.
Dr. Jumbo, you said we can use a formula sheet, but can we also use calculators?
Sure.
Okay. On our phones? I mean, that's the only calculator I have.
As long as you can apply it and answer the question and provide the right answer, that is okay.
Okay, thank you.
But of course, no copying from the text, just the formulas.
Yeah.
Okay, any other question?
No, thank you, Dr. Jumbo.
Okay, I also just recently sent an email regarding yesterday's class. So anyone that wants to take the opportunity to do that before I grade them tomorrow.
All right. Thank you, Dr. Jumbo.
All right, guys. Stay safe, and I'll see you guys after next week, I guess, for this class, right?
Yeah.
Okay.
All right. Thank you.
Thank you.
Thank you, Dr. Ingram.
Yeah. Thank you, Dr. Ingram. Thank you.
Thank you too.
All right.
Thank you, Dr. Jumbo. Have a good night.
You too.
Bye-bye.
Dr. Jumbo, how do you